Good morning, everybody, to our IDSA webinar on the IDS Reference Architecture Model 2.0. My name is Sebastian Steinbus. I am the lead architect of the International Data Spaces Association. And today, with me, Dr. Steffen Lohmann from the Fraunhofer Institute for Intelligent Analysis and Information Systems. And he is the chair of our working group architecture. He will talk about the IDS Reference Architecture Model from a business point of view. This is the fourth part of our webinar season. We already heard Lars Nagel, the managing director of the IDSA, on the context of the IDS, Dr. Christoph Quick from the Fraunhofer Institute for Applied Information Technology on the process layer of the IDS, and the last webinar was with Professor Boris Otto on data governance. So, and if you're joining our webinar live today, you can ask your questions afterwards in the questions and answers block. You can ask them directly or just write down the questions in the chat window. I will read them out loud afterwards. If you join our webinar on YouTube, just comment below or come back to us or give us an email or a call. If you like this webinar, just hit the like button. So, Steffen, I'm happy to have you here today for your talk on the IDS Reference Architecture Model from a business point of view. So please, would you go ahead?
Sure. Thanks, Sebastian, for the introduction. Hello, everybody. Good morning. Yes, I want to talk about the IDS Reference Architecture Model from a business point of view. So Sebastian is the lead architect from the association. I'm from the Fraunhofer Institute of Intelligent Analysis and Information Systems, and we were driving especially first versions of this reference architecture model, and that's why I want to go in some, give an overview over the architecture model, go into some details in some parts, and especially have a look at the business perspective and how this affects the whole IDS ecosystem. So if we look at the industrial data space, it's about data sharing within ecosystems. So we have different verticalizations ranging from material science to the material data space, to the logistics data space, or the medical data space. So in different domains, there's a high interest of sharing data, exchanging data. And I think this was already well motivated by the previous webinars. So I don't want to repeat here all, just saying that within ecosystems, data sharing gets more and more important, as well as between ecosystems. So not just within the manufacturing domain or the materials domain, but also between these different domains. Data sharing is one of the key topics and challenges this time. Data sharing, data exchange, and especially aspects, as you can see here, the interoperability to create more autonomous systems, to allow for more intelligent systems, to allow for things like the Internet of Things, to really provide end-to-end processes, also secure processes. So there's a lot there are a lot of aspects involved, and the whole material flow, which usually happens in supply chains, in smart manufacturing, in different domains, has to be complemented by an information flow that is by good exchange of data, by good sharing and interoperable management of data within these domains. So that's also one of the key challenges of the industrial data space, as it has been introduced already before. We have this big need of data exchange and interoperability along the value chain, about data-centric services. We want to create new data-driven business models. We partly need, or companies, organizations need to exchange data for legal reasons, to allow for track and trace and other things. So there is a serious business need in exchanging data within and between different organizations, companies. But there's, of course, on the other hand, this very important asset of data. Data is the new oil, so I don't want to share with all companies or everyone. So there is data ownership, which is important, data protection, and data value. And, this is honored in the IDS, in the industrial data space, and framed with the term data sovereignty. So our goal is to really given natural persons or corporate identity capability of being entirely self-determined with regards to its data. The data must be controlled by the organization, by the company, by the person that owns the data, that is want to make value from the data, or that just don't want to provide it to everyone for free without restrictions. I think this is very understandable. And if we look at business models, yes, it's especially this challenge, this balance of, on the one hand, making data available to create new business models, and on the other hand, protecting data as an asset is one of the big issues here, which need to be addressed and which are addressed by the industrial data space. So that's why sovereignty is one of the core aspects. That's why sovereignty is really in the focus of the industrial data space, and sovereignty only works if we combine several dimensions, aspects in this shared ecosystem, which is a decentralized control. So it's really about federated architectures, and this is one key characteristic of the industrial data space. It's not one third-party provider, one cloud provider offering all services, hosting the data, and in the end being of control of the data, but it's a decentral architecture so that every organization decides itself how much of the data it makes available in, for example, a cloud architecture, or how much it are remaining on their own premises, on the own service. Then scalability is an issue. So decentral systems are good, scalable usually, but of course it needs a clever architecture to allow scalability, to make this whole system work even with large data, with many participants, which is quite challenging here. It is open in regards to open to a community. It's very important that it's not vendor specific. Industrial data space doesn't follow vendor specific profiles. There's always the risk of a vendor lock-in if you use proprietary formats here. It's really the idea of having the core information parts, the core information models, the domain specific models as open as possible, at least in the community, exchanging data, so that there is not one participant being in control of these data schemas, and in the end also the data assets if it's proprietary formats. Then governance is of course an important issue. The rules of the game must be clear. It must be clear how data is exchanged, and how this is also guaranteed that only certain parts of the data are exchanged. Not everything is accessed. So there need to be clear governance rules. There need to be trust. It's very important to make sure that I know who is accessing the data, that I can identify every participant of the industrial data space, and security, end-to-end security, on-demand data exchange by still having very secure architecture is important. It depends a bit on the domain. In some domains, like the medical domain or other domains, security is really first-class citizen, while in other domains, maybe it is less important, but still I think issues also, if we look at manufacturing, like safety, security, privacy, all these aspects are of relevance in nearly all verticalizations of the industrial data space. If we look at a typical enterprise architecture stack, the industrial data space is located somewhere between the very basic services of the Internet of Things, of network connections, 5G connectivity. So this is all on the network layer, which is not really targeted by the industrial data space. Also, in the industrial data space, we are not looking at services as smart services or service-oriented architectures, as they are very popular, but we really look at the data layer in between, so where it's about exchanging data, aggregating, and making data available, especially in an interoperable way across companies, across organizations, and even across industries and domains. We have currently version 2 of the reference architecture model ready, working towards version 3. There has been a previous version last year published and a white paper 2 years ago, even more than 2 years ago. Yes, I think we have in these documents, you get a good overview over basic principles, the general architecture of the industrial data space. Of course, many details, especially implementation specific details are not in these documents. They are described in other assets and other publications, also in resources available to members of the International Data Spaces Association. But I think still this document is very valuable of getting an overview of having the right level of abstraction to understand the basic ecosystem of the industrial data space. To have a look at the general architecture, I think this illustration depicts very well the basic concept. Once again, it's about having different organizations, in this case 2 companies, company A and company B. They both have the internal IDS connector where all the data is aggregated from, for example, different production plants or from different machines or from other data sources, heterogeneous data sources in these companies. The data is aggregated and then via this external IDS connector, via a gateway, it's exchanged within the industrial data space ecosystem. This can be a third-party cloud provider where I host the data. It can be a server on my own premises. It can be some architecture which is installed in the company. And yeah, the important message here is this is data is exchanged via the internet, but it's exchanged in a secure way. It's encrypted. It's protected. And with a clear identity management and interoperability so that all people understand what's exchanged there, all participants involved, and also that these participants trust each other and are pretty sure about the identity of the other participants. Then there's something like an app store where different apps, data apps, are provided that have certain functionality. This is, of course, from a business perspective, quite relevant. Everyone knows there are popular app stores out there already for different markets and developing apps for a certain market or an ecosystem like the industrial data space is an interesting business and can lead, of course, also to some very nice return of investment here as soon as the ecosystem is set up and running. The same with the broker services. Brokers are mainly registries, so the idea is that companies, organizations can register their data assets at some broker service, make it available for money or for free if they like, but often the idea is to have some different pricing and payment models to say, I have this certain data and make it available to other participants of the industrial data space. And yes, I have this broker service to help me see which data is available, having a clear index, a registry, also some clearing services behind so that it's clear how is consuming the data, who is consuming the data, and yes, in what ways. And this is like the central registry for data sets. If there is no just bilateral connection between 2 organizations, but if there are more than 2 players involved in data exchange. Once again, the structure of the reference architecture model, I think, which is important here to understand. So we have the business layer. We have a layer where the different roles and interests of the participants of the industrial data space are described. We have a functional layer listing mainly the requirements and functional issues that have to be taken into account. We have a process layer that was already described in detail in the previous webinar, by my colleague Dr. Christoph Quicks. Then there's the information layer, which will also be described in more detail in a follow-up webinar. And we have the system perspective, where it's about the concrete implementations of the industrial data space, of connectors, brokers, and other components of the ecosystem. We have next to these layers different perspectives, starting with the security perspective, which is really cross-cutting all these different layers. That's why it's not a layer itself, but it's perspective. It affects from the business layer down to the system layer, all layers of the reference architecture model. There's certification perspective, similarly affecting all layers, which is important in the industrial data space. Participants are certified, as well as data apps and components of the industrial data space are certified. It's an open ecosystem, so there can be different connectors, there can be different brokers, there can be many different apps, but the certification guarantees and ensures that there's trust, that there is, that it's made sure that no data flow is going in the wrong direction, and maybe someone is, kind of stealing data in a way that's not according to the rules, the government rules of the data space. And then there's, governance, defining the rules, defining the whole ecosystem in a way that it's clear what's the different roles and functions of the individual participants in the industrial data space and of the components which are on which it is based on. Looking at this business layer, what we call a business layer, actually we have in the association a task force looking particularly at business models. That's the task force business exploitation. So this is more, once again, from the architecture point of view, business layer, just describing the roles and making clear in which parts of this ecosystem, there are certain business involved. So we have the data consumer and data provider as the two main contributors, as the two main business partners who want to exchange data, who want to transfer data. Then we have this broker service that I already mentioned. So a central registry where these data, especially the data provider, publishes the metadata about the data set. And then there is a data consumer or different data consumers who can search for this metadata and look if there's certain data, for example, certain data or certain sensor data that they are interested in. If there is a transfer of the data established, and there is a clearinghouse logging the transactions, so making clear that all the data exchange is logged properly, so that can be used then for billing, pricing, and that's another part of the business. So there are different payment models, and logging is important to, for many of these payment models, see how much data has been transferred actually. There is NetStore, which is another business, and can be many app providers which publish apps. This is a business on its own in this ecosystem. Then there's also vocabulary provider. So since interoperability is a big issue, since we want to make sure that data is exchanged in a semantic interoperable manner, we need vocabularies. There need to be clear schemas for the different domains. So vocabulary provider is an important issue to make data available in an understandable way, in a way that several participants or the whole community in a certain domain has agreed upon. And then there are other entities like the data owner, which is very important from a legal point of view. This is the entity that authorizes the data use to the data provider. It can be the same entity as the data provider. It can be different entities. If we have examples of, for example, in the automotive domain, where it's sometimes hard to really tell who is the data owner, if certain sensor technology is embedded in some cars or vehicles, then this is also, of course, a legal perspective, but it's very important to of course ensure here that it's clear who's the data owner and who can provide the data in whose let's say whose responsibility area. And then there's the data user, basically, that uses the data, which is transferred to the data consumer. It can also be the same in this case, but it can also be different rules. And we have this other business role of the service provider. That's typically a cloud provider, third-party cloud provider. So whenever a data provider doesn't want to make the data available in its own premises or just want to outsource the hosting of the data, which is a common case, it can hand over the data to the service provider, transfer the data to the service provider, so that the service provider taking care of hosting and managing the data assets of the data provider. But it's very important that this is not just one service provider, not just one big cloud provider, as it is often the case in central architecture. So there's this one guy who has really the power and the control of the data, but here it's a service provider, which really means it's providing the service of making the data available and taking over this role of providing the data to some data consumer. The functional architecture, the functional layer, as I already mentioned, lists all the requirements which are key to the ecosystem of industrial data space. Trust is very important part of it. We nowadays exchange data via the internet. We have different systems that we use, but identity management is, of course, a core issue here. It's very important to clearly identify the different participants in this industrial data space, so that I know who's actually accessing my data, and that I can also then decide if I allow access to this data or not. That's closely related to certification and to governance. The rules must be clear, and there must be some certification, especially for very critical parts of the infrastructure, so that I can trust also those participants by having a third party with a high, it's a high trust factor, which I rely on, and that if they certify a certain party, I can really trust this party as well. Then there's security is a very important asset. So authentication, authorization is important here. It's really about encryption, end-to-end communication, and security by design. So from the very beginning, this has been thought in this whole ecosystem. Then we have the brokering, we have the vocabularies, which are important to understand each other, to find data, to make this available via vocabularies which every participant understands. So it's not just some relational data with maybe different columns, different schemes, data schemes that no one has a clue what actually is in the data. And this is certainly a problem, that often a data doesn't have the quality that a certain participant expects. So we have in the industrial data space this sampling idea or principle, so that I can check out or test a sampling data set, a certain sample which shows me the quality of the data, and I have these vocabularies describing the data along different dimensions. So I can make sure if I, for example, need latitude, longitude values in a certain precision and reliability, this is described by the vocabulary, and it's guaranteed that I get the data I'm asking for. This is important part of such data spaces, that the quality level doesn't need always to be on a very precise level, but it must be clear what's the quality of the data that is provided. There can, of course, be also apps. This is point 5, that also do a bit of cleaning of the data, that might even improve the quality of the data. So that are used to transform maybe raw data in a format that is more easily accessible, that it's very well annotated with the vocabularies of the ecosystem. So this is also a business of just providing apps who transform data from a format which is hard to read and make use of to a format which is provided in a way that it's more understandable, that it's easier to read for the participants. And then, of course, we need interoperability, especially in data markets. It's clear we have the vocabularies, but we also need to be able to connect different ecosystems, to connect different domains, and that's why the idea of the industrial data space is really not being just one verticalization, but providing this general architecture, so it's easier even between different domains or between different areas in the industry, sectors in the industry. Data exchange is made more easy. Let's say between the manufacturing and the mobility domain, which can be quite of value, or between logistics and production, whatever. That's one of the key value propositions that we do here with industrial data space, of saying we have to standardize of interoperability, and that's also why it's important to create standards, to use standards. There are a couple of existing standards which are often a bit more domain specific, but also on this data integration and data exchange layer, they are quite generic standards which we make use of, as I will show later. And then there's the clearing billing, this whole data market concept and everything which is related to it. So there's a lot of business also there, because I need trusted entities here that make sure that the data exchange is locked and cleared in the right way. It's in the interest of every participant that this is, even if it's a decentral architecture, controlled in a way that I can make sure which data is transferred and that I also get the value for it. I don't want to dig deeper in the process layer, because this has already been deeply explained in a previous webinar. Just want to show this is part of the reference architecture, and these different processes are described in sub-processes in a clear manner, so everyone can have a look at this other webinar, or also the reference architecture model document. But I want to say a few words about the information layer and the information model, which is really core to the IDS. Just saying that there is maybe a bit less business if I think of where I can make money in the whole ecosystem, but it's really to the core of the IDS that different players, that different participants meet and discuss the vocabularies which are used to exchange the data. On the right you see a small figure just illustrating or distinguishing between the different types of descriptions, semantic descriptions of data. So we usually, and this is what's really core in the IDS, so the metadata level, the description of the data on the metadata level. That's important. We have the self-descriptions of the connectors. We have this broker registry, and they all use metadata to describe certain data sets or data assets or data dumps, which are made available by the industrial data space. Then we have vocabularies in the different domains which structure the data. That's also important, especially if we exchange data between organizations, between companies. So within a company, I usually have something like an enterprise service bus or some other architecture and vocabulary that is used. But as soon as I leave the boundaries of a company, of an organization, this vocabulary issue becomes even more relevant, because I need clear terms and terminology that describes the data in a way that it's understandable also to others. There is some mapping. So even within a company, there's usually done some mapping of these different data sources to certain vocabulary terms, to terminologies which are used by the company. But if we have it between companies, we need it on the domain level, that certain things are clearly defined that there's a mapping, that there's a taxonomy, and yeah, sometimes we talk about ontologies here. We need to make sure that the data is exchanged in an understandable way. That's mainly relying or referring to the data scheme, so the description of the data and the structure. And of course, we also can look into the data itself and exchange data in a meaningful way. But this is that goes to the payload and is not possible in all cases. In either cases, especially in cases where not large data dumps are transferred, but rather structured data, let's say geodata or sensor data or other data which has a high structure, then the payload data actually can be described by vocabularies and by the information models within the industrial data space. But yes, I think this is not always the case. It cannot always be the case. It depends very much on the payload, on the actual data that is transferred. But this information model really affects all the different roles that I described in the business model, all the different aspects that are relevant in the industrial data space. So from the individual participants, which are described, to the usage control policy, like how I can use the data, how I can control the use of the data, and how I can maybe even enforce the use of the data, and up to the services and data descriptions themselves. Here's just once more like one layered architecture to get maybe a bit better understanding of what this information model layer is about. So we have conceptual representation on a very high level, going down to programmatic representations, which are very technology specific. So we have implementations, for example, in Java or other technologies here, which can be used, which makes it much easier for developers to use the information model. But it's very important that especially this middle layer, this declarative representation of the IDS information model, of the ontologies in the different domains, are described in a technology agnostic way, in a kind of serialization independent manner, so that I can serialize it then to different representations, being it a JSON description, so in a JSON LD or JSON format, or being it XML in some, especially in some legacy systems. That's important. So it's really not a representation which is very technology specific. This is also important if you think of sustainability and future scenarios where these information models are used. Yeah, I also don't want to go too much into detail in these information modeling aspects. There is a webinar, a follow-up webinar in a couple of days by a colleague, Jaroslav Pullman, who will describe this in more depth. It's important maybe to note that the core model is openly available. That's very important for the whole ecosystem, that everyone can access it for free. So there is no business involved here, but domain-specific models, or more detailed descriptions of certain parts of the pricing or other aspects of the industrial data space don't have to be open to everyone. So there's also a bit of business involved here. So especially these domain vocabularies, domain languages within communities can, of course, have a certain pricing. The same here for the data. As you can see, the different models, classical models, like going from free data, which is also important in this ecosystem, up to flat rate or pay-per-use systems, or other payment and pricing models that are considered here in the information model. And also an important aspect of the information model, once again, not that much from a business perspective, but very much from an interoperability perspective, is the alignment with existing standards which are used already to describe data, to describe policies, to describe entities, persons, organizations. So there's a bunch of these vocabularies already. One important one, which is not listed here, is schema.org, that's used a lot in the web to describe certain entities. But others like geo vocabularies or provenance vocabularies are aligned and yeah, this is an ongoing activity, so this is just important to make sure that used and available vocabularies are well aligned with the whole ecosystem, and that we don't reinvent the wheel here, but really incorporate as much of the existing vocabularies and knowledge already in this information layer of the industrial data. And then we have the interactions on the system layer. Once again, in the reference architecture described on a rather abstract level, just to be vendor and technology independent. There are different implementations of these connectors. As you can see here, in the ecosystem, yeah, there are a couple of connectors, and it's a bit like you can compare it with web browsers on the internet. So they're different web browsers, they're different companies behind these web browsers, and the same is the case for the connectors in the industrial data space. Also, for other components like the broker, there is not just one registry, but there are different registries, and there can be one registry for every domain. So depending on which verticalization I have, it makes sense to have a dedicated registry for this verticalization. So let's say the materials data space might have a different registration than the medical data space or other data spaces. And the same for the app stores. There, of course, is a tendency that there are one or two very popular entities in this case, that there's one app store used by many participants, but this ecosystem is open. It's a decentralized ecosystem, so there's nothing preventing me to set up an app store for my particular data assets or domain and make this available. So from a business perspective, as soon as this ecosystem is set up and running in a certain domain or across domains, it's quite interesting to invest in these components and component development to then get returned by participants using these components. As it is well known from other domains, I had this example of the web and the different browsers and the different search engines maybe, which can be a bit compared, not perfect comparison, but can be compared with the brokers and the connectors. And yeah, this is in the same manner decentral architecture, which can be compared to the internet, but it's on a different layer, so has a layer on top to make data exchange really trustworthy here, according to the different aspects I mentioned in the introduction. And then we have different security profiles, all described in the information model, and it's also important, once again, to understand that different settings, different scenarios, different domains, different verticalizations require different security levels. Level 0 with non-security is not used in any of these ecosystems and domains, but not all of these aspects which are listed here have to be realized in all settings. So especially in these more free and open settings, or in other, yeah, not that critical domain settings, security is maybe less important than in others, but in all cases, basic security must be provided. So level 1 security is usually what we aim for, and level 2 is then what we call in the trusted connector scenarios is really what needs to be, yeah, make sure that this is implemented in the right way. And there is a certification topic I already addressed briefly, so I also don't want to go too much into detail here. Once again, this is more giving an overview of the reference architecture and a bit of the business that yeah, can be or that is relevant in the IDS ecosystem. But here, just an overview that this is an important aspect also of the industrial data space. So we have certification body, we have evaluation facilities, we have this idea and the concept and really these different schemes already, like an IDS ready certificate to make sure that participants are trustworthy, that they are the participants that they prevent to be, or that they tell others that they are. So this is very important to really have this trust level which can only be guaranteed by a certification model. Once again, there's an analogy to the web. So web shops are usually have a trust certification on the web, which is important. And we usually don't like to consume stuff and give our credit card details to some shop which is not certified, or it's unclear the trust level of these shops. And this is the same here. We have to make sure that the participants are trustworthy. Of course, if they are global players, if they are big companies, you usually have a certain level of trust, but nevertheless, it must be guaranteed that this is really the identity and the entity that it states to be. So this is also from a business point of view, once again, important or relevant here, because you can imagine that these roles and certification of the industrial data space are also good business models. There has to be an entity that certifies or that executes the certifications. And there's an interest, of course, also in the association of certain partners to have this job to make business and money in this regard. But it's, as I said, a very important asset and very important role in the industrial data space, also for all other participants. So it makes sense having different parties that do certification. And once again, the idea of the decentral aspect of the industrial data space means that there is not just one certification entity, one party doing this, but that there are several. There's just one authority that is the one that manages the certificates. But also here, don't confuse that there is a technical certification procedure where this is usually a hierarchical model, while this is rather from an organizational point of view, an entity certifying certain components, apps, or participants in the industrial data space. So certification has these two aspects, these two layers. One is more security, and that's why it's more described in the security perspective, and one is certification in an organizational sense, which is described here on the certification perspective. I don't want to go into data governance today for the reason that this has already been addressed by Professor Boris Otto before in the webinar, so we don't have to address it again today. So please check that webinar out if you're interested in data governance. But of course, as I said already, this is an important issue in the industrial data space as well. The rules must be clear, the rules of the ecosystem, so that's described in the governance perspective and in the different layers. Yeah, that's it. My time is over, 45 minutes for this webinar. Just want to say thanks for all who attended. I'm open to questions, and this slide briefly gives an overview of what we are doing at Fraunhofer Institute of Intelligent Analysis and Information Systems. So that's the topics, and many of them are also addressed in the industrial data space, but even beyond. So yeah, thanks for your attention, thanks for listening, and I'm happy to answer any questions that might have resulted from my introduction to this topic.
Yes, thank you, Steffen, for this very interesting lecture on the IDS Reference Architecture Model from a business point of view. Really very interesting. So for all of you who listen to us on YouTube, don't forget that you can like this webinar and comment on it below. But for everyone who's inside the webinar, we can start with a question and answer block right now. And as I said, you might write down your questions in the chat window, and I'll read them out loud, or you can ask your questions by yourself. And the common question that comes first is usually, will you share your slides, Steffen? And I've asked you before, so Steffen will share his slides and we'll upload them on our website later on. So, but are there any other questions? So as people are thinking, it seems like, I have a question to you, Steffen. So you already said a lot about the reference architecture model, and it's something like a standard. And so how does this relate, this IDS standard, to other relevant standards and standards that are used in industry and are business relevant, like IIRA or IDI or even BDBA? Do you have any idea on this?
Yes, that's a good question. It's often asked. So people say there is already the Industrial Internet Consortium, the IIRR. Yes, there is this platform Industry 4.0, especially in Germany and Europe, with these RAMI models, so the reference architecture model for Industry 4.0. There are other models, especially from the IoT domain, so IoTA, and also yes, in different regions in the world. So in Asia, there are certain initiatives, especially in China. There's a lot of industrial internet standardization going on, also in France and different countries. So yeah, that's often a good question. So what's the difference? So maybe if we compare the industrial data space and the reference architecture to other very well-known architectures or proposals like the reference architecture of the Industrial Internet Consortium, I would say that if we compare to this reference architecture, it is different in this regard that we, in this industrial data spaces architecture, really focus a lot on interoperability and also on making data exchange semantically interoperable by this information modeling aspect, which is not that much in the IRR reference architecture, as far as I know. At least I have seen little investment from their side to really model these different domains. This is a bit now followed in the industrial ontology foundry initiative. So there is certain things going on, but this is one difference. There are other differences, like it's not, the concerns, for example, are not that clear in the Industrial Internet Consortium context. But on the other hand, they have made a very good job in having this very generic architecture which can be applied to different industries, which is kind of similar to the industrial data space reference architecture idea. If we compare to other popular concepts like the RAMI, like this reference architecture model Industry 4.0, the main difference is that the data space architecture really is on the data layer. So we really focus, as I've shown on one of the previous slides, we really focus on the data exchange layer. We don't care too much about physical layers, about the real shop floor, if we think of the manufacturing domain. Also not about the office floor, but the connecting layer, which is important. And often, especially this layer, is what needs to be addressed, or what's the challenge in current digitization. So we don't care too much about these lower layers. We also don't care too much about the upper layers in the whole enterprise architecture stack, but we care about this data layer, and this is maybe the main distinction to the Industry 4.0 initiative, where especially manufacturing and production is addressed, and it's very well defined to the very basic physical layers of systems, so to the individual machines and cyber physical systems, how the communication and the whole reference architecture has to, takes place, and that's why the RAMI model is great to structure a certain domain, to structure data exchange within manufacturing, to give it some reference and some framework. But it's, as I said, not looking deeply into this data layer as we do here in the industrial data space, also with these information modeling and clear semantic descriptions. And also the security aspects I would like to highlight once again, are, I think, very well thought through in the industrial data space. The whole part of the certification, about the whole part of providing technical certificates or organizational certificates. This is not addressed that much, or let's say on that deep level in the other two initiatives and reference architecture models which I mentioned, which are also popular, and I think that's why they complement each other. But I think that's why they also have all their own focus and their own challenges that they address. I hope this answers a bit the question. Of course, it's really hard to go very deep in these different architectures today.
Yeah, a very comprehensive answer. Thank you for this. And so another question arrived. So Kevin asks, which tools or technologies are you using to create, merge, and refine and to store the ontologies and vocabularies? And I think this really hits your expert knowledge.
Yes. So actually, if we look at the technologies, we very much rely on technologies that are defined in internet context for data exchange in the internet context, which is mainly driven by the World Wide Web Consortium, which are also used by big search engines. So this is to annotate data semantically. We mainly use the reference, the RDF, the Resource Description Framework. So that's a vendor-independent standard to describe data. It can be serialized in different formats. So it can be serialized to XML, which is, as I said, still an important format in data exchange, and especially in legacy contexts. But it can also be serialized in JSON. And the important thing here, once again, to note is that this is often the header, the metadata, the vocabulary, the description, while the payload, of course, doesn't have to be JSON. It can be some binary format or some other formats too. Yes, so we use the Resource Description Framework here on a technical level, which is, I would say, the de facto standard to really have vendor-independent, non-proprietary data exchange, which doesn't prevent us to embed also, as I said, on the payload level, other models which are already used, and especially in several, if we think of 3D graphics or any CAD-related data, it doesn't make sense to really map all this on RDF. But other data, especially as I mentioned, structured data like geodata, sensor data, and others can be very well mapped to this RDF format. And then even the data itself can be transferred in RDF. But as I said, or as I showed before, the most important part is that especially the metadata and the vocabularies to describe the data are described in this Resource Description Framework in this independent and especially vendor-independent language.
Yeah, thanks again for a very interesting answer.
Yeah, I hope this answers. Maybe to add, from the protocol perspective, we are also independent in a way that we mainly focus on two protocols, which is HTTPS, of course, so TLS secured, and which is also the MQTT protocol. And then there's some specific IDSCP protocol, which we needed to design for very secure, trusted connector communication. But I think in many or most of the scenarios, you do either this HTTPS if it's more request response, or this messaging MQTT communication. So once again, it's not just one protocol that has to be followed here, but it really depends on the data exchange scenario. If you have rather this asynchronous access, or if you need messages, and you can use both, and connectors that are developed or that are currently implemented mostly speak both languages here. And then it's a multi-part message where this data is transferred as a header body, as it is well known from HTTP context, for example.
Yes, thank you, Steffen, for the answer, and thank you, Kevin, for the question. I hope too that the question is answered sufficiently, but I think so. So, are there any more questions? And so, if not, then again, I would like, of course, all of you for listening today in the live webinar, and also to all of you who listen to us on YouTube right now. And of course, I'd like to thank you, Steffen, for very interesting talk and very good, very good answers to the questions that were raised. So, thank you again, everybody, and then have the best day of all today. See you next time. Bye.
Thanks to you. Bye.